Hi everybody. I'm just going to take you through this GCSE paper from November. So this is some last minute practice for you for your mock. And it's a non-calculator paper, but obviously for you guys, you can use your calculator if you want to practice with this. So let's go through some of these questions then. LCM of 108 and 120. So we're going to need to do Venn diagram, 108 and 120. So 108 is going to be 2, that gives you 54, 2 gives you 27, 3 gives you 9, 3, and that leaves you with a 3 there. 120 will be divided by 2, gives you 60, 30, 15, 3, and 5. So now we can start to cross these out, put them in the middle. There's another 3 there. So HCF is 2 times 2 times 3, which is 12. And the LCM will be the HCF times whatever's left over. So we've got 3 and a 3 there. So that's times 9 and then times by 2 and a 5 times 10. So 12 nines are 108 times 10 is 1080. 60 people in a choir, half of the people are women. So we know we've got 30 women. The number of women in the choir is 3 times the number of the men. So that means that there's 10 men. And the rest are children. So out of 60, that leaves 20 children. The ratio of the number of children to the number of men is n to 1. So children to men, we've got 20 children, 10 men. So that's 2 to 1. So n equals 2. Work out 1 3/4 times 1 1/3. So let's turn that into top heavy. 7/4 times 3 times 1 plus 1 is 4/3. We can cross cancel and we get 7/3. And it says give your answer as a mixed number. So we divide 3 into 7 to give 2, remainder 1. The denominator stays the same. Use a ruler and compasses to construct a line from the point P perpendicular to CD. So in this case, you would need to draw an arc from here. So put your compass there and draw an arc which intersects CD at 2 places. So the distance that you make from P to that line, it needs to be slightly bigger than that, but not too big that it's going to sort of come off the line when you draw your circle. Like if you do it too big, it will come there and there. So we want it to be slightly smaller than that. So you get your arc there. That will be your circle. Obviously, I can't draw that very well. And then you can do your perpendicular bisector from these 2 points. So put your compasses there and do your circles there and the circles like that. They will cross over down here and then you can draw your line through there like that. Diagram shows triangle ABC. The size of the angle ACD is 2 to 1. So that angle there is in a ratio of 2 to 1. Yeah, so we can work out what that angle is. It's 75 plus 51 is 126. Subtract that from 180, and then you get 54 degrees. So that's 54 in total, and it's in a ratio of 2 to 1. So we're going to split it into 3 parts because it's a ratio of 2 to 1. So 3 is into 54. Go 1, carry 2, 18. So this is 36, 2 times that, and 18 in there. Work out the size of angle BDC. So we actually want this angle in here. So 51 plus 36 is 787. 180 minus 87 is 93. Four red bricks have a mean weight of 5 kilos. 5 have that. Okay, so This is a weighted mean, so we're going to multiply these. 4 times 5, 5 times 9, and 1 times 6. So we've got 20, 45, and 6. Add those together, we get 71. So the new mean will be 71 over 10, which is 7.1. So Donna would be incorrect, because the mean's actually 7.1 and it's not less than 7. Simplify that, we multiply the powers, and then we do 12 divided by 6, that gives you 2. X to the 7 divided by x cubed, you subtract the powers to get x to the 4, and y cubed divided by y is y squared. Right, scale drawing shows the positions of port P and lighthouse L. That's the scale. Alina sails her boat on a bearing of 70. Right, I can't do this on here, but you would put your protractor on there and measure from P, from north, 70 degrees, which if 90 is due east, so it's just sort of, oh, actually, 70 degrees is, it's got a little, about there. And she sails for 1.5 hours at 12 kilometers per hour. So 12 kilometers per hour times 1.5 hours gives me, well, half of 12 is 6. So add that on and I get 18 kilometers. The scale is 1 centimeter. 1 centimeter represents 4. So if I divide 18 by 4, so divided by 2 is 9, divided by 2 again is 4.5 centimeters on this scale. So I would measure 4.5 centimeters on the page, and that would be port Q. Okay. Find the distance of Q from lighthouse L. So you would measure, try and make that accurate, that distance there. And the bearing, so if we're going north, the bearing of port Q from lighthouse L, we're going to start there and we'll measure clockwise from north. So we need that whole bearing there. It's easier to measure this in here and do 360 minus that. I can't do that on the computer, but you would be able to measure that bearing there using your protractor and then subtract it from 360. The car travels for 18 minutes at an average speed of 72 kilometers per hour. How far will they travel in 18 minutes? So we need 18 out of 60. That's 18 minutes in hours multiplied by the speed. That will give us the distance. So speed times time. 18 out of 360, if we cancel that down, is 3/10. So 3 times 72 is 216 over 10. That's 21.6 kilometers. David says that 72 kilometers is faster than 20 meters per second. Is David correct? Okay, so you can convert 20 meters per second into kilometers per hour if you like, or you could say that that car was traveling at 72, so that traveled 21.6 kilometers. So 18 minutes is equal to 18 times 60 seconds. So that would give us 18 times 6. 6 8s 48, 6 1s 108. So times by 60 would be 1080 seconds. So that in that time, that's 18 minutes is 1080 seconds. If they're traveling at 20 meters per second, that's 20 times 1080 meters. So we're going to double 1080 and get 2160, and then times it by another 10 is 21,600 meters. which in kilometers, if I divide by 1,000, is 21.6 kilometers. So if you travel at 72 kilometers per hour or 20 meters per second, you go the exact same distance. So in fact, 72 kilometers per hour is 20 meters per second. So David is incorrect. Cumulative frequency. So we're going to plot the endpoints. We always plot the endpoints here. 40,5. 60, 25. 80 was 35, I think. 138 and 40 for 120. So you would have to kind of plot this curve like that. Find an estimate for the interquartile range. So we need a 75% and 25% on here. Let's do 75% would be going across at 30 because it's 40 in total. And 10 would be the 25%. So what we have here is each of these is going up in twos, so about 46 and 68. So subtract those two and you get 22 for the interquartile range. One of the 40 is chosen at random. Use a graph to find an estimate of the probability that this person took between 50 and 90 minutes to complete the puzzle. So 50 and 90 is there. That's going across there. And 90 would be up there. That's just under there. So if we read off these values here, we've got 13 and 37. So we subtract those and we get 24 out of 40 people did their crossword between those, 24 and 40. So the probability is 24 out of 40, which is equal to, if we divide by 4s, we get 6/10. So 60% is a probability, or 0.6 or 6/10. It'd probably allow all of those. There are P counters in a bag, 12 are yellow. Let's take at random 30 counters from the bag, 5 of these. So 5 out of 30 were yellow. That's 1/6. So approximately 1 in 6 chance of getting yellow. Now, if the 12 counters are yellow, that's 1/6 of the total. Then we can times both sides by 6, and that'll give us the number of counters in the bag, just as an estimate. T equals Q over 2 plus 5. Here's Spencer's method to make Q the subject. Right, so if you multiply by 2, you have to do that to every term. So you can't just times T by 2, you've got to times that by 2 as well. So you need to put that into some sentence about multiplying every term, including the 5. So the 5 would be a 10. Single fraction, so we cross multiply 5 times 3x over, well, let's do it as a total one like that. Oops. 5 times 3x plus 2 lots of x plus 1 over 3x brackets x plus 1. So I've cross multiplied and done the common denominator by multiplying those. Got 15x plus 2x plus 2 over that common denominator. And we can collect them together to get 17x plus 2 over 3x brackets x plus 1. Factorize that for 1 mark. So what you would do here is see what term is in both? So we've got an x plus y in brackets in both, so we can take that out as a factor. And what I would have in the first term here is an x plus y, and in the second term we got a 3. So that would be that factorized fully. Right angled triangle, the area is that, so we need half base times height, and that equals 27.5. 27.5. So I'm going to multiply both sides by 2, x minus 2, x plus 4. That clears the half, but I need to times the right-hand side by 2. 27.5 times 2 is 55. Expand the brackets, x squared plus 4x minus 2x minus 8. Bring the 55 across as well to make it equal to 0. X squared plus 2x minus 8 minus 55 is minus 63. This will factorize. We've got x, because we need 9 and 7 to differ by 2, plus 9 minus 7. So x can be equal to negative 9 or 7, but we can't have a negative length, so we're going to take x equals 7. So it's greater than 0 because we're subtracting 2 and adding 4. So if x is negative 9, we'll have negative lengths. So if x equals 7, the shortest side will be the x minus 2, not the x plus 4. So x minus 2, shortest side is x minus 2, which is 5 centimeters. Express 0.418 recurring as a fraction. So we always let x equal 0.41181818 ... And because we have 2 dots, we just multiply by 100. That's the kind of pattern with this. If it's 3 dots times 1,000 times by 100, we would have 41.8181. So when you multiply by the correct thing, the decimal places will line up, and you subtract them to clear all of these. So working from the right side, you'll see that 8 take away 8, 1 take away 1, 8, all of those will disappear. All of those will disappear, and we're left with 8 take away 4, 1 take away 0, and 4 take away 0. So x is equal to 41.4 over 99, but we're not allowed to have decimals in a fraction, so we'll make that 414 over 990. You can cancel that down if you want, but that will probably be allowed. Rationalize the denominator times the top and bottom by root 11. And we'll have on the top 22 root 11 over root 11 times root 11 is 11. And they will cancel to give 2 root 11. This one, we're going to have 2 root 3 minus 1. We always times by its opposite, 2 root 3 plus 1. That will clear the denominator's surds. So on the top, we have root 3 times 2 root 3 is 2 root 9 plus root 3 times 1. And on the denominator, we have 2 root 3 times 2 root 3 is 4 root 9. And then we have plus 2 root 3 minus 2 root 3. They cancel, and we have minus 1 times plus 1. So 2 root 9 is 2 times 3 is 6 plus root 3 over 4 root 9 is 4 times 3 is 12 minus 1 is 11. Similar cylindrical containers, the surface area in the ratio of 4 to 9. So that means that the length of A compared to B is going to be the square root of those, because remember, the area is the square of the length scale factor. And that means that the volume is going to be the cube of the length. So that's 8. 2 cubed, 3 cubed is 27. So I have to fill container A and pour it all into B and keep repeating. So if I do it one time, that's going to be 8 of the 27 to fill up B. So we're going to do that's 1 time, 2 times, 3 times, and then I need to fill it a 4th time to get the extra 3. So I'll have some left over, but it says the number of times that Tyler fills container A. So that's going to be 4 times. If you do it 3 times, it won't be enough. Question 18 is a function question, and it asks us to show that the inverse function of 50 equals 3. What that means is that we can take the answer and put it into the original one, and we should get 50 because the inverse and the reverse are related in that way. So if we do f of 3, that should give us 50. 2 lots of 3 cubed minus 4 is 2 times 27 minus 4. That's 54 minus 4, which is indeed 50. The functions g and h are given by these. Find the values of x, so gx, we're going to do gx first, which is x plus 2. We're going to put that into h. So h of x plus 2, wherever you see an x, you're going to replace it with x plus 2. So it's x plus 2 squared. That's equal to x squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4. So what the question's asking, this is hgx. It wants to know for which values is that equal to 3x squared plus x minus 1. So we're going to put that equal to x squared plus 4x plus 4 is equal to 3x squared plus x minus 1. We're going to solve this equation, so we're going to collect them all on the right-hand side. Subtract x squared, I get 2x squared. Subtract 4x from both sides is going to give me negative 3x, and subtract 4 from both sides gives me minus 5, and then 0 on the left. So factorize this. We need negative 3x, so we'll start with plus 2x and minus 5x, like that. So x equals negative 1 or 5 over 2, so 2.5. Okay, question 19 is tricky. We've got a mixture of 9, 27, and 3, so we need everything in base 3. So let's see if we can turn 9 into 3 squared to the minus a half. Multiply the two powers to get 3 to the minus 1. Then we can do 27 to the quarter. This is the same as 3 cubed to the power of a quarter. I'll multiply those to get 3 to the 3 quarters. So now I've got 3 to the minus 1 is equal to 3 to the 3 quarters divided by this 3 to the x plus 1. And see how I've got all of these in power base 3, the big 3 at the bottom. Let's tidy this up a bit. We've got 3 to the 3 quarters. Because we're dividing, we're going to subtract, and I've got x plus 1 there, so I'm going to keep that in brackets. And now I can actually ignore the base 3's, and I've got minus 1 equals 3 quarters minus x, and then the minus times plus 1 is minus 1. So I'm going to take the negative x over the other side and make it positive x. And I've got 3 quarters minus 1, and I'm going to bring the negative 1 over, make that positive 1, and these two will cancel out. So x equals 3 quarters. We have a function here. On the grid, draw the graph with equation y equals f of x plus 1 minus 3. So if it's inside the brackets, it affects the x, and it's plus 1, so it does the opposite to that, which is minus 1. So all of the x values are going to be shifted minus 1. And the negative 3 outside the brackets affects the y, so everything's going to be shifted down by 3. So I have to take this whole graph, shift it 1 unit to the left and 3 down. So if I take this point here, 1 to the left, 3 down, puts it there. A, move it 1 to the left and 3 down, we'll put it down there. I'll take this point here, 1 to the left and 3 down, puts it there. And that one, 1 to the left, down there. So I would get this. You would draw this with single straight lines with your ruler and a pencil. Point A is minus 2, 1. When the graph is transformed to the equation y equals f of minus x, point A is mapped to point B, write down the coordinates. So f of minus x from your revision is a reflection in the y-axis, So that minus 2 will be reflected to positive 2, and the y value will not change. Sketch this graph showing the coordinates of the turning point and the exact coordinates of any intercepts. So if you want to find a turning point, you can differentiate, or you can complete the square, and that will give you that for a quadratic. So let's complete the square. I'll take the 2 out as a factor, x squared minus 4x minus 2.5. And then I can complete the square on the bit inside the bracket. So we're going to have x minus 2 squared minus 2 squared minus the 2.5. 2 brackets x minus 2 squared. So minus 4 minus 2.5 is minus 6.5. And then I multiply that out to get 2x minus 2 squared minus 13. So I've times 6.5 by 2. So remember, when you complete the square, that will give you the coordinates of the turning point. So the coordinate of the turning point is the opposite of this number here, so positive 2, and the negative 13 is the y coordinate, so it's going to be down here at 2, negative 13. That's the turning point. When x is 0, that gives you the y-intercept. So when x is 0, we get y equals negative 5. So it's going to cross at negative 5. So we can start to see that our curve is going to do this kind of thing. And we now need to know the x-intercepts. So we have to solve this equation, y equals 0. So we're going to do 2 brackets x minus 2 squared minus 13 equals 0. Take the 13 across, divide by 2, and I get x minus 2 squared. Take the square root, and I get plus minus square root of 13 over 2. And then I'm going to add 2 to both sides to get x equals 2 plus minus square root of 13 over 2. So when I add the root 13 over 2, that will be this point here. So that is 2 plus root 13 over 2. And this point here is 2 minus root 13 over 2. If you wanted to differentiate, let's just do that quickly. To do the turning point, we would do dy by dx equals 2 times 2, 4x, and reduce the power by 1. And then the negative 8x would differentiate to minus 8. And I put that equal to 0 to find turning points. So 4x minus 8 equals 0. Take the 8 over and divide by 2 to get x equals 2. So that tells you that there's a turning point at x equals 2. And to find the y coordinate, I do y equals, and I substitute x equals 2. So 2 lots of 2 squared minus 8 lots of 2 minus 5. So that's 2 times 2 squared is 8 minus 16 is -8, -5 is -13. So my coordinate of my turning point is 2, -13, which is what we did with the completing the square there. So 2 different ways of doing that, but you still need to solve the equation anyway, so you may as well complete the square because you already have that information that you need. Question 22, prove that triangle ABC is congruent. So that means it's just the same in terms of its angles and lengths as DCB and ABC. So can we highlight these? This one and that one. And the other bit of information that we have is that AED is an equilateral. So that, and that is 60, 60, 60. So how do we go about proving that those 2 triangles are the same? So we need to find the lengths of these and the angles. Well, let's just start with what we can do here. We've got some shapes that we can use. We've got the vertically opposite here. So you would have to write down your kind of thinking here. So CEB is 60 because of vertically opposite. So then we're starting to think, well, maybe this and this are the same because we've kind of got this triangle here. How can we go about doing that? Well, if you kind of turn your head to one side and do A, B, C, D, but this kind of shape, hopefully you can see that 60 there is equal to this one in here. So EBC is also 60, but this time it's the angles in the same segment. So you would use that argument to say that that angle in there is 60. So we now found that, which must mean that this is 60 angles in a triangle add up to 180. So at each stage, we're kind of putting our thinking in. So we've now shown that that's an equilateral triangle as well. So what else do we need? Well, if this is an equilateral triangle, then EB and EC are the same length, and AE and DE are the same length. So therefore, DEB or DB, the length DB must be equal to the length AC. So we're using that property of an equilateral triangle in terms of its length because we've added DE and EB together. DE plus EB, it must be equal to EC plus AE. So we've now shown that they're the same length. BC is the same length because it's an equilateral triangle. And then we have DC and AB. Okay, so they must be the same length as well because we've got this angles in the same segment again with this bow tie shape, but this time it's kind of like that way around. Okay, so you can use all of those arguments to prove that those 2 triangles are the same length and they have the same angles within them. Okay, that's the end of the paper. So for you guys, this GCSE is slightly different at times in terms of the content, but hopefully this shows you that there are some things you can do to practice before our mock and gives you a good opportunity to see what things they could possibly ask, because there's a lot of overlap between the GCSE and IGCSE papers. Okay, good luck.